Okay, this is the explanation for how to work the problems on your last exam. That would be exam 3, covering chapter 12, 13, and 14. This first problem is from chapter 12, and we're going to use this function. C of x is equal to 5x minus 3 over 6x plus 1 to find the average cost for 30 chocolate bars. And your average cost, which is C bar of x, is the total cost divided by the number of bars. Which means in this case, it is C of x, which is the total cost, divided by x chocolate bars. And since we're talking about the average cost for 30 bars, that's the cost of 30 bars divided by 30. So that's going to be 5 times 30 minus 3 divided by 6 times 30 plus 1. And then that entire quantity is going to be divided by 30 to get the cost per bar. And to facilitate the calculations, I have entered here into the calculator in y1 the function 5x minus 3 divided by 6x plus 1. So from the home screen, I can simply hit the vars key, go to yvars, choose function, and y1, and in parentheses, enter the value 30 to find the value or the cost of 30 bars. And that total cost for 30 bars, and remember this is in hundreds of dollars, is 0.812200, which in actuality is $81.22. And we're going to divide that by 30 chocolate bars. Which means that the resulting answer, 0.02707, in $100 is going to be $2.71 per bar. So basically, in a batch of 30 bars produced, the cost of each bar is $2.71. That's the idea of what average cost is. So in the next question, question number 2, says find the average cost for X chocolate bars using correct notation and units. Okay, we're going to use the same idea that the average cost, C bar of X, is equal to C of X divided by X, which is the same thing as C of X times 1 over X, which makes the algebraic part of this function easier to evaluate. So C of X is 5x minus 3 over 6x plus 1, and we're going to multiply that by 1 over x, which gives us 5x minus 3 over 6x squared plus x, $100 per chocolate bar, when X bars are produced, or for a batch of X bars. You need to be sure that you have the units for C average of X is $100, because going back to the original problem, the total cost is $100. So even when you divide that by the total number of chocolate bars, that's still going to be $100 per chocolate bar, and then X tells you how many bars that you're actually producing in a batch. And then it says simplify the function to make it easier to take its derivative. So we're going to go ahead and take the derivative of that function, because we're going to need it in the next question. So the derivative, C prime of X, is equal to the denominator, because this is a quotient rule, you could do it with a power rule, but it's actually simpler in the long run to do this with a quotient rule. So it's going to be the denominator, 6x squared plus x, times the derivative of the numerator, which is going to be 5, minus the numerator, which is 5x minus 3, times the derivative of the denominator, which is going to be 6 times 2 is 12, x to the first, plus the derivative of x is 1. And that's going to be divided by the quantity 6x squared plus x, and that quantity is squared. And you can simplify this a little bit if you want to. It isn't absolutely necessary. If you do simplify it, then you're going to have 5 times 6x squared is going to give us 30x squared plus 5x minus the quantity 5x times 12x is 60x squared, minus 3 times 12 is minus 36x, 1 times 5x is plus 5x, and negative 3 times 1 is minus 3. And since that's all going to be over 6x squared plus x quantity squared, we'll go ahead and try to simplify that by saying that this is 30x squared plus 5x minus 60x squared, since we're subtracting the first term. Minus 36 plus 5 is minus 31x, but we're subtracting 31x, negative 31x, so we're actually going to add 31x. And then minus times the negative 3 out here is going to be plus 3. So when we put all of that together, 30 minus 60 is negative 30x squared plus 36x plus 3, which will be the numerator of C average prime. I'm sorry, I left my bar off over here. So C average prime of x is equal to negative 30x squared plus 36x plus 3 over the quantity 6x squared plus x quantity squared. And the reason that we want that function is because in the next question it asks us to find the marginal average cost function. And we know the average cost function, C bar of x, and marginal means take the derivative, which is the rate of change function. So this is going to be the rate of change in the average cost. And that's going to be that function that we just came up with. Which was C average prime of x is equal to negative 30 x squared plus 36x plus 3 divided by 6x squared plus x, quantity squared, and that's going to be $100 increase if C average prime is positive, or decrease if C average prime is negative in the average cost of one bar in a batch of X bars. So keep in mind that is a rate of change. That's very important that you realize that that is a rate of change. So when it says to find and interpret, first we're going to find the marginal average cost function, or actually just the cost for 30 bars. So that's going to be our next chore. So we're going to use this function, C bar prime of 30 is equal to negative 30 times 30 quantity squared plus 36 times 30 plus 3 over 6 times 30 plus, and that's 30 is squared, plus 30, and that quantity is squared. And because the arithmetic on that is a little daunting, although it's not impossible, what I did was on my y equals menu, I have on y1 the actual cost. I have on y2 the formula for the average cost. So for example, I can verify that y2 of 30, which would be the cost per bar, was that $2.71. And I can also find, since what I have in y3 is the derivative of the average cost, so this is the marginal average cost, then I can also use that function evaluated at 30 to get the answer to this arithmetic problem that we have in front of us. I want you to notice to read all the number. This is the same value that you would get if you actually substituted in negative 30 times 30 squared plus 36 times 30 plus 3, hit enter, and then divide that by the complete quantity 6 times 30 squared plus 30 all squared. It actually comes out to be negative 8.78992299, and that e negative 4 says that's 10 to the minus 4 power that we're going to multiply by. So what that means in reality is we're going to move this negative sign 4 places. we could continue on with that, but because we know that this is $100 per bar in a batch of 30 bars. And since that's hundreds, that means we're going to move this decimal back over 2 places. Then C average prime of 30 is actually negative 0.0. We're going to let that 8 round that 7 up to 8. So that's going to be 0.088 or negative 0.09 dollars per bar. So what that tells us when we interpret that, is that if a batch of 30 chocolate bars is made, then the cost per bar, or you could say the average cost, is decreasing by, and this is about 9 cents per additional bar. And the reason that we know this is negative, once again, the reason that we know it is decreasing, because a derivative tells you something is decreasing, present tense. And it's decreasing because this is a negative amount. And we know that $0.09 is about 9 cents per additional bar. Now, it would also be acceptable, and your book uses this same notation quite a bit. It is also acceptable to write that in this way. The 31st bar cost would be 9 cents more than the 30th. Because in a practical sense, that's actually what that means. But that's the interpretation. Just being able to do the math is not the focus. You need to be aware of how to explain what the answer means to somebody that has no idea what marginal average cost is. Next, we have 2 implicit differentiation functions. The first function is 4x squared minus 7y squared equals 24, and it specifies, given the implicit function, show that this is the derivative. Now, yes, you can solve that for y. It involves a square root. But when you do that, the derivative you get is in no way going to look like this, and you're not going to know if that's actually what you got or not. So you need to do this with implicit differentiation. So remember, in implicit differentiation, what you're doing is you're treating y as a function of x. So anytime you differentiate y, or anything that involves y, there's going to be a dy dx. or a y prime. That's going to be a result of that differentiation. So the first term is 4x squared, and 2 times 4 gives us 8x, and 2 minus 1 means that's to the first power, minus the derivative of 7y squared is 2 times 7 is 14, y to the first power, and then because y is a function of x, we either write y prime or dy dx. Equals, and the derivative of a constant, as always, is 0. So then the first thing we want to do is we want to separate the dy dx terms from the non-dy dx terms. And you can either subtract 8x from both sides, or you can add 14y dy dx to both sides. It doesn't matter which way you do it. It's all going to come out in the wash. So when I add 0 to negative 8x, I get negative 8x. And that's equal to negative 14y dy dx. And now I need to divide off this negative 14y on both sides, which will get rid of it on this side and leave me with just dy dx. And because 2 will cancel, or 2 will divide into both, actually negative 2 will divide into both negative 8 and negative 14. Negative 8 divided by negative 2 is positive 4. And negative 14 divided by negative 2 is positive 7. Then we have now verified that the derivative is 4x divided by 7y, which was what we were supposed to do. Then our next problem has a quotient rule on one side and y as a function of x on the other side. And again, it's implicit. So the derivative of 3y squared is 2 times 3 is 6y to the first power. And then because this is a function of x, then we have a factor of dy dx is equal to, by the quotient rule, denominator goes to the top, 5 minus x times the derivative of 5 plus x, which is 1, minus 5 plus x times the derivative of 5 minus x, which is negative 1, all divided by 5 minus x squared. So 6y dy dx. Before we try to do anything with this 6y, and that's not 6 prime, that's just 6y, we really need to try to clean this up so that we can more easily divide both sides. So what we're going to do then is we have 5 times 1 is going to be 5. Minus x times 1 is minus x. 5 times minus 1 is negative 5. And x times negative 1 is negative x. But this is being subtracted. So what we actually have then is 5 minus x. Minus negative 5 is plus 5. And minus negative x is plus x. All again still divided by 5 minus x squared, which is going to be, since the negative x and positive x cancel out, that's going to be 10 over 5 minus x quantity squared. And now we need to either multiply by 1 over 6y or divide both sides by 6y. And in reality, it's actually easier if you'll think about just multiplying by the reciprocal because of what's on the other side. So those 6y's cancel, which will leave us with just dy dx on this side. And 10 times 1 is 10 over 6y times 5 minus x, quantity squared. But again, because both 10 and 6 are even, we can divide both of those by 2. Which leaves us with dy dx is equal to 5 over 3y. And there is a typo there. That is supposed to be a 3. 5 over 3y times 5 minus x, quantity squared. And I think we did correct that typo in class. So there's your correct derivative. And if you need to, you should pause the video, make sure that you understand where everything came from. Number 7 is another implicit derivative function. That's because implicit derivation is something that's important. You'll see a problem on your final exam. So when we're doing this problem, the key thing to remember is that this particular term is a product. This is actually x squared times e to the y. So we're going to have to use the product rule to find that derivative. So when we do that part, we're going to take x squared times the derivative of e to the y, which is, of course, e to the y, but because y is a function of x, we write dy dx, plus e to the y times the derivative of x squared, which is 2x. Now we'll deal with the rest of the function. This is plus y, so the derivative of y is dy dx. So we've taken care of plus y, and that's equal to x cubed's derivative is 3x squared. So now I have dy dx here and dy dx here. This term does not have dy dx, so I need to subtract it from both sides. And now I have a dy dx in both of the remaining terms. I have one here and I have one here, so I need to factor out dy dx. And then when I do that, what I have left here is x squared times e to the y. And what I have here is just the understood 1 that was in front of that. And that is equal to 3x squared, and it usually is better to write 2x in front of the e so that you don't lose track of the x. So that's 2x e to the y. And now the only thing remaining to do is to divide both sides by the quantity x squared e to the y plus 1. Which removes it from the dy dx and leaves us with dy dx, which is what we're looking for. Is 3x squared minus 2x e to the y over x squared e to the y plus 1. which was what the stated answer was. And again, pause if you need to. Go back over your steps, go back over my steps. Make sure you understand where everything came from. And if you don't, then you need to ask a question before Thursday. So number 8 and number 9 are both tangent line problems. And I actually gave you the tangent line. The equation of the tangent line here is going to come out to be 3/4 x plus 25/4. The curve that it's tangent to is x squared plus y squared is equal to 25. So the first thing we need is we need to know what is the derivative, or dy dx, because the derivative, or dy dx, is the slope of the tangent line. So when we do the slope and we evaluate it, we should come out with 3/4. First thing we need to do is take this derivative. The derivative is 2x plus 2y, and then because y is a function of x, it's dy dx. And again, the derivative of 25 is 0. So we will subtract 2x from both sides. And we have 2y dy dx is equal to negative 2x. Then we'll divide both sides by 2y, which will leave us with just dy dx is equal to 2 cancels 2, but the negative sign stays, so it's negative x over y. And because we are told an x and a y pair, then we know that x is actually negative 3, and we know that y is actually positive 4. So when we evaluate the derivative, negative 3 over 4, then the slope is going to be positive 3 over 4. And that is, in fact, what the slope is. So then we go to y equals mx plus b. Even though some of you use the point slope formula, you'll come out with the same thing. So given that, we know the slope is 3/4. We know that y is 4. We know that x is negative 3. And the only thing we don't know is the value of b. So 3 times negative 3 is negative 9 over 4. And of course that's just 4 plus b. So we're going to take 4 plus 9 over 4 is going to give us the value of b. And we have a calculator that will do the fractions for us. So we're going to turn the calculator on, and we're going to say 4 plus the fraction 9 over 4. And have it give us the answer as a fraction. And it says that's 25 over 4. So with this information and this information, then we have confirmed that the equation of the line is y equals 3/4 x plus 25 over 4. The second example works exactly the same way, except we have different values. So again, we need dy dx, because dy dx is equal to the slope of the tangent. So dy dx is 2x plus 2y. dy over dx is equal to 0. And just as it was up here, it actually turns out that our derivative is going to be the same as what the derivative was before. Negative x over y. So an interesting thing that you might want to remember here for a little shortcut is, as long as you've got x squared plus y squared equals a constant, the derivative, dy over dx, is always going to be negative x over y. And the only thing that's changed here now is that x is 8 and y is negative 6. So that means our slope, negative times negative is positive, and that's going to be 4 over 3, which is what it says that the slope is. And again, y equals mx plus b. Y is negative 6 equals 4 over 3 times x, which is 8, plus b. 4 times 8 is 32 over 3. So negative 6 minus 32 over 3 is going to be equal to b, and the arithmetic can be done on our calculator. And it is negative 50 over 3. So that means that y equals the slope, which is 4/3, times x minus 50 over 3, which is what we were told that it was. Question number 10 is about the price of beef in the United States. And it says that the price of beef in the United States has been found to be dependent upon the demand. And remember, demand is a price. And it's measured per capita consumption according to the equation Q, which is quantity, how much beef, is equal to 342.5 over P to the 0.5314 power. And we know that elasticity, E, is equal to P over Q dq dp, which is, of course, the derivative of this quantity. So it's this derivative that we need. Now, several of you tried to do this with using a negative power so that you could avoid using the quotient rule, and that's fine. Or you can use the quotient rule. The algebraic path should lead you to the same derivative in either case. I'm going to use it as a power. So rather than leave this down here, I'm going to put it up here and just change the power to a negative. Which means then that my derivative is going to have the power come down in front. And it's going to multiply times the 342.5 P, and then when I add 1 to that power, I'm sorry, not add 1 to the power, subtract 1 from the power. Then what I'm actually going to have is, let's just go ahead and multiply out the 342. So 342.5 times negative 0.5314 is negative 182.0045. And that's times P to the negative 1.5314 power. So that's dQ dP. And P, of course, is just P. And it's going to be divided by Q, which is this expression that we were given for Q. Now, since this is dividing by a fraction, this is actually simpler if we will do this. Simply multiply by P to the 0.5314 power over 342.5 and wind up with that quantity, and then again times the derivative. And then the thing that you need to remember here is your rules for exponents, because this is P to the first and this is P to that power. And the rules say that when you have the same base with different powers, you add the powers. So that means this is E is equal to P to the 1.5314 power times negative 182.0045 P to the negative 1.5314 power, all divided by 342.5. And what happens is, again, here you got P to this power and P to this power, but when you add this power to this power, you wind up with P to the 0. So that's P to the 0 times negative 182.0045 over, and remember this is times, it's not a subtraction, over 342.5, and that's the value of E. And remember that P to the 0 is 1. So our final answer is that negative 182.0045 divided by 342.5, which turns it back into negative 0.5314. And the entire quantity of E, which I have left throughout this whole thing, left out, this entire formula is negative to start with. So all of these all the way down have been negative. Which means that negative times negative gives you the final value of E, which is positive 0.5314. And that tells you that E is less than 1. The fact that E is less than 1 tells you that the demand for beef is inelastic. When demand is inelastic, what that means is relatively small percentage increase in price will result in a relatively small decrease in demand. And the actual percentage of that decrease is going to be the value of E. But inelastic means that one increases, the other decreases, but a small percentage increase results in a small percentage decrease, and vice versa. If demand had been elastic, a small percentage increase in price would have resulted in a large decrease in demand. But inelastic means small increases goes into a small decrease. And once again, here are the calculations, leading basically to the fact that E is 0.5314. And one thing to remember, even though I left out my negative sign all the way through, be careful at the end that the value you're going to come out with when you do all of the multiplication is going to be negative, but because the value of E is negative, negative times negative, E is always going to be positive. It's just a question of whether it's less than 1, equal to 1, or greater than 1. And in this case, it was less than 1. Problem number 11 says, given the function f of x is equal to negative x cubed minus 12x squared minus 45x plus 2, use the derivative to show that f of x has critical numbers 5 and negative 3. So that means the derivative, f prime of x, is going to be negative 3x squared minus 24x minus 45. And we know that we find critical numbers when the derivative is equal to 0. The first thing that I notice here is that every term of the derivative not only is negative, but it also can be divided by 3. So I'll factor out the negative 3 to make it easier to solve. I could use quadratic formula straight out. You could use quadratic formula straight out, but because we can factor out the 3, it'll make the numbers we deal with a little simpler. And because we've already been told that the critical numbers are negative 5 and negative 3, we should realize that this function actually factors. So this is negative 3 times x squared plus 8x plus 15. And that's equal to 0. And x squared plus 8x plus 15, the factors of x squared are x and x. The factors of 15 that will add and give us positive 8 are going to be 3, and 5, which means that x plus 3 is equal to 0, which gives us x equals negative 3. And x plus 5 is equal to 0, which gives us x equals negative 5. And these are the critical values. Which has verified what we were told. So then we need to verify that f of x is increasing on the interval -5 and to -3, and decreasing on the intervals negative infinity to -5, and -3 to positive infinity. So what we do is we draw a number line, and on the number line we place our critical values, -5 and -3. And then once we've done that, since we're looking to see where f of x is increasing or decreasing, we're not interested in where the values of f of x are positive and negative. We're interested in where are f prime, or where is f prime of x greater than 0 and less than 0. That's what we're interested in. So remember, f prime of x is equal to -3x squared minus 24x minus 45. So we need to evaluate f prime of, let's say, -6, and f prime of, let's say, -4, and then f prime, we could use 0, but I'll use -2, just for the sake of consistency. And since we're going to evaluate the same function over and over again, it would be actually much easier to go over here and actually put in the original function in y1. We'll use our calculator to help us as much as we can. So the original function is -x to the third minus 12x squared minus 45x plus 2. We're not really interested in the average, so we're really only interested in the derivative, but not of y2, so I'm going to clear that out. Go math, number 8 to get the derivative, and ask it to find me the derivative of the function in y1 with respect to x at any value of x that I ask for. And as we did in class, we can actually quit and do all of our arithmetic here on the home screen, or we can simply make sure our table is set up to let us ask for x values, and then go to the table, and we can ask it for values of x that we have here on our number line. So I'm going to ask it for -6, -5, -4, -3, and -2. And what I verify then is that at -5, even though the value of the function is 52, the value of the derivative is essentially 0. That's a numerical derivative, remember, so that's actually 0. And the same thing happens again when x is -3, so that confirms our two critical numbers. And then at -6, we see that f prime of -6 is less than 0, because it's -9. Therefore, here the function is decreasing, 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 decreasing until it gets to -5. And then for the number between -5 and -3, we have 3. So f prime of -4 is positive, which means the function now is increasing, 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 increasing. And then again at -2, it's back to being negative. So the derivative is negative, the rate of change is negative, which tells us that the function is now decreasing. So what that tells us about the function is that it is increasing on, excuse me, let me not do that there. Let's do this here. It is actually decreasing until it gets to -5. Then it increases and at some point reaches a maximum. And then at -3, it begins to decrease again. Which confirms what we're told, which is that it was increasing on the interval -5 to 3, which we see here, and that it was decreasing on the interval -infinity to -5 and -3 to +infinity, as we see here. So you have to both verify your critical numbers and then use your derivative to verify where your function is increasing and decreasing. Our last problem is a problem about the total profit. It says the total profit in thousands of dollars from the sale of X 100 grams, pay attention to the units, 100 grams, profit is thousands of dollars, is given for this prescription drug by the natural log of this function that we have here. And that function is only valid on the interval from 0 to 10. So we're going to use the derivative, which means we're going to look at the rate of change. Because that's what a derivative is the rate of change of the function, to show that the maximum number of units that should be sold to maximize the profit is 600 grams, and the maximum profit is about $5,784. So we need the derivative of p of x, which is p prime of x. And p of x is a logarithmic function. And the derivative of a logarithmic function is 1 over the function, is 1 over whatever you're taking the log of. So the derivative of this is actually a chain rule problem, because the thing that's being taken, the natural log is being taken of, is a function itself. So the derivative is 1 over the original function, -x cubed plus 3x squared plus 72x plus 1 times the derivative of what's being taken the natural log of. So we need its derivative as well. And the derivative of -x cubed is -3x squared. And of 3x squared is +6x, and of 72x is +72. So the derivative actually turns out to be -3x squared plus 6x plus 72 over negative x cubed plus 3x squared plus 72x plus 1. And we are interested in where that function is increasing and decreasing on the interval from 0 to 10. Because the place where it changes from increasing to decreasing is going to be where we find its maximum. So the first thing we need is we need to find the critical values. Which is where the derivative p prime of x is equal to 0. That's going to have to be our first step. So with that in mind, this is equal to 0 only if the numerator is equal to 0. It doesn't matter what the denominator is. If the denominator is dividing into 0, then the result is going to be p prime is going to be 0. So we're only interested in where the numerator is equal to 0. And just because I noticed that negative 3 will divide into all of these, I'm going to see if this will factor. So then I get negative 3 times x squared minus 2x minus 24 is equal to 0. And that does, in fact, factor. We need factors of 24 that will add up and give us negative 2. And those factors are 6 and 4. And it'll be a negative 2 if x is minus 6 and plus 4. X plus 4 equals 0 gives us x equals negative 4. That's not in the interval. So we will discard that one because it isn't in the interval from 0 to 10. However, x minus 6 is equal to 0. Gives us x equals 6. So that's our critical value. And the critical value is where the derivative is equal to 0. So if this is a max, then we need to verify what's going on at 0 and 10. Because we need to know if it's doing this or if it's doing this. If it's doing this, we're in trouble. So in order to check that, all we need to do is actually evaluate that derivative at 0 and at 10. Now that's a difficult derivative to evaluate, so I'm going to use the function itself in y1 like we did before. So that's going to be the natural log of negative x cubed plus 3x squared plus 72x plus 1. And then I'm going to leave y2 as the derivative of the function that's in y1 with respect to x for whatever x I ask it for. I'm going to go to the table, and just for the sake of aggravation, since these are all negative, we're going to delete all those out. And we're actually only interested in what happens when the derivative is 0, what happens when the derivative is 6, and what happens when the derivative is 10. And we see that what happens when the derivative is 0 is that f prime of x is positive, which tells us that the function is increasing, which is what we were hoping for. And we see that when we have f prime of 6, that we are at the critical value 0, and that at f prime of 10, f prime of 10 is less than 0, which tells us that we're negative, 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 which tells us that we're decreasing, 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 which indeed we are. And that verifies that the function, the profit function, is at a max at x equals 6. So in terms of the problem, when 600 grams of the prescription are sold, the profit is maximized at, and then the calculator helps us out again here, at x equals 6, the value of the profit function is 5.7838, or about $5,784, because this is in thousands of dollars. Once again, from the statement of the problem, P of x is in thousands of dollars. So be sure to watch your units. It's more than about the numbers. You have to be able to explain what the numbers mean. Hopefully this helps you with the next exam and helps you with the final exam, and I will see everybody next class period.